So in this problem, we have a boat that travels 60 kilometers eastbound, due east, and then it adjusts its course by 25-degree northwards and travels another 90 kilometers in that direction. And the question is, how far is the boat from the initial position to the nearest kilometer? Well, again, what I'd like to do is show, this is just a triangle problem. We've got two vectors here. One vector is 60 kilometers long. That's the magnitude at an angle of 0 degrees because that's the eastward direction. And then when the second vector takes into place, it kicks in at 25 degrees northward of that horizontal, 25 degrees northward with a magnitude of 90 degrees. So what we have here is a triangle. The resultant vector is the gray line starting from the origin. So there's our start position at the origin. What we need to do is figure out the distance from the origin and maybe even perhaps the angle if you wanted to, but that'd be easy to do. But the first thing that I would like to point out to you is that you actually have a nice oblique triangle here for which you know two of the sides. You know the 60 unit side and the 90 unit side. You also happen to know the angle between those two sides, and that angle between those two sides is equal to 180 degrees minus 25 degrees. So what you know is that you have two sides and the contained angle, or the angle between them. That angle works out to be 155 degrees. So what we'll do is I'm going to resketch this triangle here on the next frame. And we've got two 60 kilometer side and a 90 kilometer side and the contained angle, and I'm going to recommend to you that you use the cosine law, because the cosine law is always easy to implement if you know any two sides and the angle between the two sides. So here it is right here, and now it's just a straight calculation. So eventually, don't forget that once you worked out the right hand side, you will need to take the square root to come up with a value for r.